Hello, this is the course PowerPoint and presentation I have for the Duke AI Product Management course. Today we'll review the user experience for the product. We'll evaluate the privacy and ethical implications of the product. Then we'll have a quick analysis from the task analysis, user experience design. We're really focusing on minimizing the impact to the user at all. Privacy considerations, there's some laws in our application that we're going for, and some ethical considerations. So before you start a product or anything related to a product or features, you just don't jump in. You need to define the product. So one way that you can do that is using a value proposition canvas. This really focuses you to look at the customer profiles, what jobs and tasks they do, what pains they have, and what they want to gain, or what they can gain from the problem that they have. Then you have to look at the proposition that matches up with the customer profiles. The customer has pains and gains. The proposition should have pains and gains as well as products and services. When you look at the customer profile and the proposition, you can get alignment on what you want to do with the particular product. Then you have to align the problem or proposition to make sure that there's a product market fit. So it's just because you may have a great idea, that doesn't mean that you would actually do it if it's not a product market fit. And then you have to align key metrics and the delivery. A lot of times when you think of delivery, there may be various channels with which you deliver a feature or a product. Only when you go through this, understanding the value proposition, the product, the customer segment, uh, all the tasks they want to do, can you start to brainstorm solutions? When you brainstorm solutions, you have an opportunity to set first principles. Really, what are the guiding things you're trying to do with your solution? You can look at the risk, and there's a lot of risks for machine learning. There's some more ethical risks on how you use the data, depending on the application you have. And then a success criteria. So really brainstorming problems, making sure they align with your value proposition and your product market fit is key. So as you notice, this is all about defining the problem, not solutioning the problem. So I'll kind of jump right in, assuming we've done the value proposition and as well as making sure it aligns with the business model. So the problem statement I'm looking at is if you're a dentist in a dentist office, when dentist, you go into the office, they will create a period chart. The period chart will have what looks like pictures of teeth, and each one will have a pocket depth. Now, this is important because types of treatment and payment are determined based on the number of teeth and the pocket depth. And this is typically a very manual process, error-prone, when people have to count the number of teeth in a segment and look at the pocket depth for each teeth. So it creates a lot of rework. So if we could figure out how to do this automatically without changing any workflow in the dentist office, then we can really find a way to do it quicker and have more accurate treatment. So when you back down, this is a solution to the problem at a high level. We can use machine learning to scan and process these charts to automatically determine the pocket depths, then populate the data in the clinical system. So all the dentist has to do is when they're normally going in and reviewing your record before you go, it will be automatically populated, and another person in the office won't have to manually populate that. So that means that there is time that you can give back to the dentist office. hygienists or other people. It also means the billing is accurate. And so there is a lot of errors when an office, a provider's office, do not send in the correct data. So let's look at overall task analysis. I keep this at a high level. The trigger for this is when a Perio chart is generated. So the solution will need to hit an API to hit a service that will extract the information from the chart. That's where the machine learning model will come into play. Then that will populate the system, and a dentist will go in and look at through the clinical system and will review and approve uh, the pocket depth information, which will dictate treatments that can or cannot be done. And then finally, there'll be a message sent out to the claim system so this can be paid. So it's kind of a task analysis. From the user experience design, really thought hard about not impacting the user experience. When you get into these clinical offices, they have set workflows, set systems, and that sort of thing. So you really don't want to impact it at all. And so in this particular case, we're just have the exact same workflow, the exact same user interface. What we don't do is have a user go in there and manually entering the individual tooth metadata. So some privacy concerns. In the healthcare space, there are significant privacy concerns. There are HIPAA implications. There's claims information. There's clinical notes information. So this system with the machine learning model cannot expose any of that information. That means you have to do the proper encryption. You have to also segregate your data that may have personal identification information. Likewise, when you're doing training, you need to make sure that training data or the data sent back for training from the systems do not have personally identifiable information. Then, if you're over in Europe, they do have also similar requirements. And so that has to really be able to take in consideration. So that's a user experience design, really thinking about empathy. Really want to make this machine learning algorithm and the application around it to be invisible. Some ethical considerations, of course, of privacy and consent. That is paramount in this space, in the healthcare space. Training data and bias is extremely important. Make children or the pocket depth information algorithm could work differently for one group or another. So that's something to really understand clearly. You have to make sure that the machine learning model is explainable. People do not like to use, and healthcare professionals and providers do not like to use algorithms that they cannot explain. Secondary uses of data. You can have aggregators, you can have other providers, and other healthcare insurance components that use the data. So you have to be very explicit in the secondary use. Patient needs to have control of their data. It's very important. They're in healthcare space, especially in the government space. There's interoperability requirements around the data. So this data that gets generated around clinical notes, clinical actions for the patient needs to follow those requirements. Then there's healthcare regulations. We mentioned HIPAA. There's different requirements for government programs and commercial programs. And finally, it's very important to do an ethical review and approval. You really need to think closely. I would not think about this as a bad thing. The more eyes you have on this, the better.